All right, so this is our review for number systems. Really kind of a short unit. We're not going to have a full-blown perform level test. This is going to be a test you can do a bunch of retests on. I think I'm allowing 3 retries on it, 2 or 3, something like that. So the plan is to go through this assignment and then use this to prepare for the quiz that'll be tomorrow. That assignment, it's not meant to be open notes. It's not meant to be calculator active, at least not the first time. If you want the second, third time, go nuts. Go ahead, use this, use your notes, use anything. Just the first time, just do it on your own. Anyways, let's go ahead and go through this. Number 1, what is the exact value of 22 over 7? So if you remember from Monday, we did that worksheet that went through our notes kind of. In order to convert from a fraction to a decimal, all you are going to do is divide. So we would just do 22 divided by 7. And of course, going back to like 6th grade, you add a decimal because we're obviously going to need to keep going. And we'll add some zeros because I'm going to tell you right now, there's going to be some borrowing happening. So 7 goes into 2, it doesn't. 7 goes into 22 3 times, so we can confirm the first number is 3. We subtract 21 from that to get a remainder of 1 and bring down the first 0. 7 will go into 10 1 time, so again, we can't rule anything out yet. Subtract 7 from there to get 3. Carry down the next 0. And 7 will go into 30 4 times. So again, we can't rule anything out quite yet. So 4 times 7, 28. We'll subtract that to get our leftover of 2. But we can confirm now it's not A and it's not B. Because if I add another 0 and carry this down, that's going to be 20. And clearly 7 does not go into 24 times again. So it's not A, it's not B. We just need to confirm, is it going to stop way down here at this 7, or is it going to keep going? Okay, D is if it keeps going, C is if it stops at the 7. So we know it's going to be a 4, and then a 2, and then an 8, and then a 5, and then a 7. We just don't know for sure if it's going to keep going past there. So we'll add all these zeros. So let's see, 2 times 7, 14. We'll go ahead and subtract that. Carry down the next 0. 7 goes into 68 times, which is 56. Subtract that to get 4. Bring down the next 0. 7 goes into 40 5 times, so that'd be 35. Subtract that. We get a leftover 5. Bring down this last 0. 7 goes into 57 times, which would be 49. And this confirms that it is not C. Because when we got down here, we still don't have a remainder of 0. We have a remainder of 1. So for number 1, it's going to end up being D. And as a quick heads up, so that you're sure, anytime you are dividing by a 7, it is going to be an infinite repeating decimal. It's not going to terminate. It is going to keep going. Number 2, it's asking us to label these sets of numbers. They're either rational or irrational. So remember, a rational number is anything at all that can be rewritten as a fraction. Irrational, those are infinite non-repeating decimals. These are things that can't be converted. So let's see, 6.3, that is rational. So yeah, that means it can't be this one because we know 6.3 is rational. 4 pi. Well, 4 pi is definitely irrational, so far can't rule anything out. Square root of 12. Square root of 12 is also irrational. So far we can't rule anything out there. But this one says square root of 100 is irrational, and that's not true. The square root of 100 is 10, because 10 times 10 gives us 100. So it can't be this one either. This is the one that has everything labeled correctly. And just so that way you're aware, 7.89 repeating, that can be written as a fraction. It would just be 7 and 89 over 99. So that is not irrational. Go ahead and move on from there. Let's see. Number one, we got D, and number two, we got A. So D, A. This is where you're going to enter your answers, by the way. The test is going to be formatted more normal, but the repeating decimals are hard to type. Which real number is irrational? Okay, so all of these are real numbers, but one of them is irrational. It's not D, it's not C. Those are quite literally already fractions, so no. B, it's 3 times the square root of 5. There is no square root of 5, so that's going to be my answer. A, while this does look funky, the square root of 16 is just 4. This is just saying 1.9 times 4, and that is normal. That is something we can calculate. For number 4, which choice best represents 4 over 9 as a decimal? Shortcut is, if you remember our notes, a repeating decimal is just going to be that number that is repeating over a 9. If you remember that, you already know the answer is C. It's going to be 0.4 repeating. If you don't know that, you can do it the old-fashioned way and do 4 divided by 9, add a couple of zeros, and you'll see that 9 goes into 40 4 times. And that'll be 36, and it's going to repeat a 4 forever and ever and ever and ever and ever. So yeah, number 4, it's going to be C. And number 5, which statement is true? So this goes back to our first day of notes on Wednesday. All integers are rational numbers. Yeah, that is true. All rational numbers, or all integers are rational numbers. B is not correct. A rational number can be a decimal, integers cannot. C is not correct because natural numbers are numbers that you can count. Rational numbers, you don't really count those. And all whole numbers are natural numbers. Almost. 0 is a whole number, but not a natural number. So, number 5, the answer would be A. So going back, 3 is B, 4 is C, 5 is A. What did I say? B, C, and A, I think, is what I just said. Yep. Number 6, we have 1 over 22. This one's asking which one is equivalent. All right, well, let's go ahead and get started. We have 1 divided by 22. So to do this, we'll just add a decimal and a 0. Looks like we'll have to add a few zeros based on my answer choices. 22 doesn't go into 1 at all. 22 doesn't go into 10 at all. 22 will go into 100. It looks like 4 times no matter what. So 4 times 22, that's going to be, I think, 88. So we'll subtract 88 from this. And that's going to give me an answer of 12 if I do all the borrowing, which I am skipping that for right now. Bring down this 0. 22 will go into 120. It's going to be 5 times. So 5 times 22, that's going to be 110, I believe. So 110. So it gives me a leftover of 10. Add another 0, bring it down, and we can start ruling out some answers. So first of all, it doesn't look, we already know 22 is not going to go into 100 evenly. So we know it's not going to stop at the next number. We just don't know for sure if it's that the 5 is going to start repeating, or if it's going to repeat 0, 20, 45, or if it's going to repeat the 4 and the 5 over and over again. We don't know what the pattern is yet. 22 goes into 100. We already know this 4 times, so it can't be C. We just don't know. Oh, wait, we do know. Because here, the 0 would be repeating next if it was A. So no, it is not A. Correct answer is B. It's going to be a pattern where the 4 and the 5 alternate over and over and over again. So this is going to be my answer for number 6. For number 7, what is, let's see, 0.12 repeating as a fraction? Remember our notes. If it is a repeating fraction, you're just sticking it over a 99. And I forgot to say this yesterday, but you would simplify if possible. But 12 over 99, that cannot be simplified. So number 7 is simply going to be C. So number 7 was C, and we got B for number 6. Moving on to number 8. It says, which choices represent 0.6 repeating as a fraction? Choose all that apply. So why would we say choose all that apply? Well, that's because, remember what I just said on that last problem, we have a 6 and we would put it over a 9, an equal number of 9s in the denominator. So 6 over 9 can be simplified. That can be simplified once, all the way down to be 2 over 3. So yeah, this can be simplified a little bit. It could also be partially simplified to be 4 over 6, meaning my answer to this could either be C or it could be E. Those two are equivalent to 6/9. So for number 8, we have 2 answers. It is C and E. There we go. And number 9, which categories does the number square root of 14 belong? So square root of 14, that is an irrational number. That means it's not an integer. It is an irrational number, so B would work. It's not a natural number because we wouldn't count it if we were just counting stuff. It's not a rational number. We obviously, irrational, rational, they're not the same. Real number, yeah, it exists at least. And whole number. So the answer to number 9 would be B, and it would be E. So B and E, irrational and real. For number 10, what is pi represented as a fraction? So this one was a trick. Pi is irrational, and that means it cannot be represented as a fraction. So the answer would be D. Pi cannot be represented as a fraction because it is irrational. For number 11, we have the square root of pi versus pi over 4. So this one you kind of have to think. Square root of pi, that's about the square root of 3, more or less, kind of. That's the closest thing that we can think of. Versus over here, we have pi over 4. Well, that's basically 3 over 4, about, roughly. And we kind of talked yesterday what the square root of 3 would be. We talked about what, if we had to guess what it might be, and Gabe came up with probably about like 1.7. That's pretty close because 1.5 would be a little too small. So whatever this is, it's about 1.7, which is bigger than 3/4, which would just be 0.75. So the answer to number 11 would be A. Okay, we want to use the greater than symbol. And number 12, it wants us to order these from least to greatest. So again, just like that last problem, we have to do some estimating. We have to do some guesswork. So least to greatest. So first of all, pi. Pi is easy. We can round that to about 3. Square root of 8. Whatever square root of 8 is, we know the square root of 9 would be 3. Whatever the square root of 8 is, we know it's less than 3. It's like 2.9. Which is not going greatest to least, or least to greatest. So A is not going to work. B, same thing, we kind of already talked about it. Pi, we already said that's maybe like about 3.1, something like that. And then we've got the square root of 8, which we don't know exactly, but we can guess it's probably like 2.9. It's really close to 3, but not yet. And then we've got the square root of 2 over 4. The square root of 2, whatever that is, it's got to be a little bit more than 1, because 1 times 1 would be 1, and 2 times 2 would be 4. So this part up here, the square root of 2, that's probably like 1.2. So we could just round that down to like 1/4. Like this is going to be really small. So it should be this one first, which automatically gives us D. And then it would be this one second and this one third. All right? In general, for these ordering problems, it's best to make that list off to the side and start comparing them. But let's see. Number 10, we got D. Number 11, we got A. And number 12, we got D. Number 13, which points on the number line best represent the square root of 110 and the square root of 50. So we talked kind of about this yesterday. You can just straight up make a list of all the square roots. You can do 2, that's the square root of 4 because 2 times 2 is 4. 3, well, that's the square root of 9 because 3 times 3 is 9, and so on and so on. And this is going to give you a really, really good jumping off point to kind of work with. That way you can reference all of these as you're working. And it's not cheating if you write this when you start the test. It's cheating if you write this before the test and then you pull it out and you start referencing it during a test. But if I like start a test or start a quiz and you immediately write all of these down, just so that way you have the list sitting off to the side, that's not cheating at all. That is 100% exactly what I want you to do. That's why I've told you about this hack, because it's totally allowed. Why did I write 100? This should say 10. And I'm just writing a bunch of them so that way I can use this for the next few problems. This table over here, I'm going to keep up for the rest of the video probably, just because it's useful. And 12, that's the square root of, got the equal sign. That is the square root of 144. I'll just keep this over here. So square root of 110. Well, 110 would be between 10 and 11. So between 10 and 11, that's going to be K. Square root of 50, that would be between 7 and 8. That's probably J. So J and K is going to be my answers for this one. All right. For number 14, on a number line, which integer would be closest to the square root of 83? Looking at our chart over here, 83 is really close to 9. So number 14, we would say 9. So we've got B and B for 13 and 14. For number 15, it's asking us to order these from least to greatest. So again, we're going to make a chart off to the side. We've got 6.1. Well, 6.1 is just 6.1. 45 over 7. Well, let's see. 7 goes into 45, 6 times evenly. And then it would have a remainder of 3. So a remainder of 3 out of 7. Probably closer to like 6.4, 6.5. And then square root of 37. That's also going to be really, really close to 6. So this one is going to be 6. What would that be? 6.1. I wonder what 6.1 times 6.1 would be, if that would be too big. Let's go ahead and double check just to be sure. So 6.1 times 6.1, because this is the only one we're not too sure about. And this is meant to be a hard problem because this is a problem that could happen. 1 times 1 is 1. 1 times 6 is 6. Done. All right. 6 times 1 is 6, and 6 times 6 is 36. Let's add that together and see what we get. We get 1, we get a 2, carry the 1, we get a 7, and we get a 3. 2 decimal places. So 6.1 times 6.1 would be 37.21. So 6.1 is actually too high for the square root of 37. So whatever this is, it's got to be 6.08, 6.09. Whatever it is less than 6.1 or 6.10 because it's the same thing. So my answer should be that the square root of 37 comes first. So these are out. Square root of 37 should come first. Then 6.1 would be the next smallest. So for number 15, we would get B. All right? Really tricky, but this is how you would do it. You would experiment and try to see, is this number going to be small enough or big enough? Number 16, which would represent the square root of 7? That's going to be between 2 and 3. So it's point A for number 16. And what did we say it was for 15? 15, we said B. Number 17. So number 17 is a reasoning problem. This one is asking how you would solve a problem, not necessarily what the answer is. It's asking what describes how to plot an approximation for the square root of 14. So it wants you basically to explain the notes that I had you take the other day, which is how would I find the answer for the square root of 14? And the way that you would do that is you would determine which two numbers are the squares directly above and below 14. You would look for the square roots that are really, really close, which is 3 and 4. Square root of 9, square root of 16. And then you would place the point between those two integers, between 3 and 4. That's how you would do it. For number 18, again, really easy. If you have this chart, it's asking you to guess what would be closest to the square root 11. Let's see, 11 is closer to 9 than it is to 16. So it stands to reason that the square root of 11 would be closer to 3 than to 4. So we got A for both 17 and 18. For number 19, it's asking between which two whole numbers is the square root of 250? Square root of 250, well, we know it's definitely got to be more than 12, but is it really going to be all the way up at 25? No, it would be A. It would be between 15 and 16, because if I do 15 times 15 and multiply those, I'm already getting 25. 5 times 1 plus 2, that's 7. Placeholder, 1 times 5, and 1 times 1. Already, just 15 times 15, we end up with 225. That's already pretty close. So it's not going to be B, C, or D. Those are way too high. Let's see. And the last problem is going to be, where would the square root of 150 lie? Well, you can see already 12 is the square root of 144, so 13, just so you know, if you want to write this down, 13 is the square root of 169. So square root of 150 would be between the square root of 144 and 169. So it's going to be C for this one. So 19 was A, and 20 was C. Let me go ahead and hit submit, make sure there were no errors and no typos before you guys take it. There might be a typo. Hold on. Number 6. Number 6, it's saying that one is wrong. All right, let me check. Okay, actually, reviewing this, it's looking like I did make a mistake. When you're doing this, I think I crossed out C by mistake. The correct answer is C, because what's going to happen is the answer will be 0.0, and then 4, 5, and 4 would be the next number, which does not cross out C, because then it would be 4, 5, and then it would be 4, 5. 4 and 5 will alternate. So this is the pattern where the 4 and the 5 are repeating. B, the one that I chose incorrectly, would look a little bit closer to this. It would be 4, 5, 4. 4, 5, 4. This is what C, or what B is saying, which is incorrect. So my mistake on number 6, that is the only error, but that does mean that there are no mistakes anywhere in the actual assignment. So when you're going through this, again, it would be a very good idea to have this information off to the side. But otherwise, this is generally the only thing for this mini unit. And I say mini unit because we're really only touching on this because it's something you'll be tested on. I've already mentioned this isn't something that you would really use. If you are going to use radicals and square roots in the real world, in like a future profession, you're going to be looking for exact numbers, not just estimating. So yeah, that is basically all of that for this unit. Good luck tomorrow. Remember, don't use a calculator or any of your notes the first time. The second and third time, go ahead, you can use your notes, you can get help. But that's going to do it for this. Hope this helps, and I hope you actually watched it so you can be ready for tomorrow. Bye-bye.